In this problem, we need to show that the sum of vectors originating from the vertices and pointing towards the midpoint of the opposite sides of a triangle results in a zero vector. Now let's try to understand this problem with the help of a diagram. We have a triangle with vertices A, B, and C. Now D, E, and F are the midpoints of the side BC, CA, and AB of the same triangle. Now we join point A and point A with a vector directed towards D. Then we have BE, which is a vector going from B to E, and CF is a vector going from C to F. Now we need to show that the sum of these three vectors are the medians of the triangle ABC. So the sum of AD vector, BE vector, and CF vector equals the zero vector. Okay, let us begin. So first we are going to name the position vectors of the vertex A, B, and C. So here, let's say we have some origin O of our coordinate system. And then if we draw a vector joining point O and point A directed towards A, then the position vector of A is going to be given by A vector. And we suppose that the position vector of point B is B vector and the position vector of point C is C vector. Now, the next task will be to define the position vector of point D, E, and F. That's a very simple task because AD is median on BC. We can say that D divides BC in the ratio 1:1 internally. So we can apply the internal section formula to find out the position vector of point. So to find out the position vector of point D, we will take this one and multiply it with the position vector of C. We have 1 times C vector added to this one will get multiplied with the position vector of the vertex B whole divided by 1 plus 1. This is going to give us the vector B added to the vector C whole divided by 2. So now we have the position vector of point D. Similarly, E divides AC in the ratio 1:1. So we can define the position vector of point E. So that is going to be A vector plus C vector divided by 2, and the position vector of point F will be A vector plus B vector divided by 2. Fine. Now let's find out the vector AD. So A vector, now AD vector, so that will be defined as OD vector minus OA vector. Now what is OD vector? OD vector, that's B vector plus C vector divided by 2, minus A vector, that's going to give us B vector plus C vector minus 2 times A vector, all divided by 2. Fine. Then we have BE vector. The BE vector will be OE vector minus OB vector. The OE vector, that's given by A vector plus C vector, all divided by 2, minus B vector. Combining them gives us A vector plus C vector minus 2 times B vector, all divided by 2. And then we have the vector CF. So CF vector will be OF vector minus OC vector. So that will be equals to, the OF vector will be, we have A vector plus B vector, all divided by 2, minus the vector C. That gives us A vector plus B vector minus 2C vector, whole divided by 2. So now we are going to add all the three vectors, AD vector plus BE vector plus CF vector. So when we sum it up, we will find that this sums up to the vector 0. And this successfully proves our problem.